Hello friends, welcome back to our channel. So in today's session, we'll see one more concept in generative AI, that is the architecture that is going to be followed by all the pre-trained LLMs. So in our previous session, we have discussed about what exactly means the LLM, and now we'll see the architecture behind the working of LLM. So we have seen what is an LLM. LLM stands for large language model, and these LLMs will generate the output based upon the user input. So these LLMs are the AI models which will be trained from the large data sets, okay, from number of books, articles, or internet, whatever it may be. So these LLMs are the pre-trained AI models. Now, see, for example, let us take one chatbot, okay, any assistant. If you want to book any railway tickets, so obviously we'll be having one chatbot or chat assistants will be there, and we can ask our queries and automatically it will give the response, okay, based upon our questions. How this happens? Okay, so here we are giving some input, and so it was analyzing the input and it was generating the output, right? So this is done with the help of this architecture called encoder-decoder architecture. So here the architecture behind all the predefined or pre-trained LLMs is encoder-decoder. So this is the architecture. So this is called as neural network design. So neural network design, so which was used in pre-trained LLMs. Pre-trained LLMs. So majority all the LLMs will be using this encoder decoder architecture, and this will be suitable for sequence to sequence data. So sequence to sequence means the input will be the sequence of words and the output will also be the sequence of words. So such type of LLMs will be using this encoder and decoder. Now we'll see what exactly means the encoder and decoder. So the encoder means it will be taking the input, understanding the input. So unless the model understands the input, so it doesn't generate the output. Okay, so encoder means understanding input, whatever the input we are giving, that will be understood by the model. And coming to the decoder, so from the understanding of the input, the decoder will be generating the output. So decoder means the responsibility of decoder is generating output. So this kind of architecture will be used in the sequence to sequence pre-trained LLMs. Okay, so encoder understanding the input, decoder generating the output. Okay, so this here the encoder doesn't generate any output, but it will be understanding the input given by the user, right? Now what are the components of these encoder decoder? Components of encoder and decoder. So first one is working of encoder, so how it will be working, and the second one is the working of decoder, and the third one is attention mechanism. So as we said that encoder means, so it will be understanding the input, and decoder means it will generate the output, and attention mechanism will be connecting this encoder and decoder. Okay, so this attention mechanism will connect both the encoder and decoder in order to get the accurate result. So we'll see one by one. The first one is an encoder. The working of an encoder. So encoder, the working of encoder. So how it will be worked? So first step, it will take the input, okay, in the form of sentence. So it takes complete sentence. So we will be giving the input in terms of sentence, a group of words. So complete sentence at a time. Okay, it will take the complete sentence at a time. What's the next step? So the next step is a tokenization. Tokenization. So what is meant by this tokenization means the complete sentence will be divided into different parts. Okay, so here I'll write sentence divided into words. So a grouping of words, we are calling it as sentence. So tokenization means it will divide the complete sentence into different words. And the next step, conversion of words to numerical. So this numerical we call it as a vectors. Okay, so whatever the words it was divided from the sentence will be converted into vectors. Okay, now encoder attention is used to find relationship between words. Okay, so we'll be having a different words. Now the encoder attention will be using to find the relationship between the words, and finally we'll be getting the complete understanding of sentence. So that means we can say it as an output, encoder output. Okay, this is an encoder output. So this will happens in the encoder phase. Okay, it takes the complete sentence at a time, and the tokenization first the complete words will be, complete sentence will be divided into different words, and after division the conversion of words will be done to the numericals, vectors, and then positioning will be done. Okay, that means it gives the relationship between different words, okay, of a sentence, and finally we'll be getting the encoder output. So in all these steps the new content will not be get generated. Okay, in all these cases new content was not generated. Now coming to the decoder. Decoder is very simple. So takes encoder output as input. Okay, so whatever the output given for the encoder, that will be taken as an input for this decoder, and takes token by token rather all at once. So the quite opposite of the encoder. So here the encoder takes a complete sentence at a time, but here it will take a token by token, rather all taking at once. So instead of taking the complete things at once, it will take token by token. Okay, first token, and the next predicts next word, only one word. It will predict only one word at a time. Okay, it doesn't predict the complete text at a time. It will predict only one word based on previously generated. previously generated words. So whatever the words that have been already generated, from that it will predict the next word, whatever the next word. Okay, so this will be happens in the decoder and this happens in the encoder. So encoder will understand the input and decoder will generate the output. Now the third component is attention mechanisms. So there are three types of attention mechanisms. So as I said, that attention mechanism will connect the encoder and decoder in order to understand and produce the output. So the next component is attention mechanism. So the first one is encoder self attention. Encoder self attention. So what does it mean? Means, as we said, it finds relationship. It finds relationship between words of a sentence, whatever the input we are giving. And the second one, the similar decoder self attention. Decoder self attention, and this will predict next word from previously generated words. So all this we have discussed in decoder and encoder. So the same thing, but this attention mechanism plays a very important role in this encoder and decoder architecture, right? And finally, the third category is encoder decoder attention mechanism. So one is a encoder, one is a decoder. Next, encoder decoder attention mechanism. So this will be finding importance of words from encoder output and generates next word. So from this wording you can understand the attention mechanism will connect both the encoder as well as the decoder. So by using this architecture, whatever the question you are posing to the LLM model, so it will understand the grammar or a pattern and it will reconstruct the sentence, and finally we'll be getting the generated text, that means the output. Okay, so now what are the examples that uses this encoder and decoder architecture, right? Examples. So what are the LLMs that are being used, the this architecture, encoder and decoder architecture, is T5 model, BART model, MT5 model. So these are a few examples that follows encoder decoder architecture. So these are the few models, example LLMs, pre-trained LLMs, so which are being trained from the massive data sets. Okay, and applications where we are being used these applications. As I said that this kind of architecture will be used in sequence to sequence model. So where we are giving the questions and where we are getting the answers. So the first one, the question and answers, the chatbots where we are using this question and answers assistants. Okay, and summarizations. So in few LLMs we are supposed to give some very large data and we are asking about summarize the complete data in a few words. So it's such type of things also used here. And translations, language translations. So if you want to convert one language to another language, first it will have to understand the given language, and then it will be converted to the next another language. So these are a very few applications where we are using these encoder and decoder architecture, okay, for the pre-trained LLMs, right? So obviously the advantages of using these LLMs, the data which was generated is accurate, and it will be very uh, perfect, right? So hope you understood this architecture. So that is a encoder decoder, okay. So encoder and decoder, so which is encoder means understanding the question, and decoder means responding to that question, okay. If two persons were communicating, one person is asking the questions and another person is going to respond. So if the question asked by one person is properly understood, then only the second person can easily generate or respond to that particular question. So both are very important, encoder and decoder. So this same architecture will be used in pre-trained LLMs of sequence to sequence, right? So I'll stop here, and hope you enjoyed the session. And if you really understood the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.